Uh, it occurred to me before we can talk about Go modules that we need to cover something called semantic versioning. And if you know what semantic versioning is, stop the video right now and go about your business. But if you have never heard of it before, you have no idea what it is, this is going to be the fastest summary that I personally can come up with to tell you about semantic versioning. And then we're going to talk about how semantic versioning um, has been problematic, specifically in the use of Go based on the specification. And to get to the point, some of you may have noticed that many Go modules are zero dot, right? They don't seem to care about that major word. We're going to talk about that and why that is, and talk about the problem with it that's inherent to it. And there will be another video later that talks about Go modules, but you can't understand Go modules until you understand semantic versioning. So let's dive into that. Here is the specification on semver.org. This is not news. There's probably a ton of videos on this. But let's go ahead and just read it. Given a version number major.minor.patch, and you'll see people in tech circles talk about the major version number, the minor version number, the patch version number. These are terms that you probably want to memorize if you're going to be involved with anything. Even if you're operations, you're never doing code, you're never writing code. Semantic versioning is used all over the place. In fact, semantic versioning is used to version device driver levels on occasion. Semantic versioning is sometimes used to identify standards. Actually, so it's everywhere. It's not just software. Is the point I'm trying to make. So it's worth learning. A major version. It says here, major version when you make incompatible API changes. Now, this we're going to come back to number one. This is the most problematic of all of them. This is the most problematic of all of them. This is the one that causes a lot of grief for a lot of people who take this versioning system seriously. And really, the only way to get around it is if you just ignore the spec. And we'll talk about if you should do that or not. The major version, when you make an incompatible API change. To give you an example of this, let's say, so if you're working in Go, Go has this promise of compatibility, right? So, or if you want to go back to the dark times of Python 2 versus Python 3, which has largely been rectified by now, then you're talking about breaking changes. So breaking changes means something has happened so that the code that you once had does not work under the same thing. This is less of an issue for Go because Go is compiling binaries, and those binaries don't care about the version. Whereas in Python, if you had the wrong version installed, same with the Java JVM and any interpreted language, these things are much more significant because if you don't have the right interpreter, you can't even run certain code. And these other languages have gotten around this problem by bundling, a virtual environment, Python virtual environment. So we don't need to go down that rabbit hole right now, but that is all largely related to the major number. And again, the final binary that comes out of Go or Rust or Crystal or any LLVM language is, independent of anything else until you go to rebuild it. And that's what we need to get to. So the minor version, when you add functionality in a backward compatibility manner, you add functionality in a backward compatible manner. The most frequent change is usually to the minor version. And you'll see minor versions. You'll see versions of code that'll be like 0.140 because that minor version has gone up so high. In fact, if I want to, just for fun, I want to see what the Perl current version is. Perl, kind of died on the vine. It's kind of sad. I love that language for so many reasons, but Perl 6 was a very, very breaking backward compatibility change. And it made it really, some people could say that Perl 6 killed Perl because they tried to do everything with Perl 6. I've been following this for several years. But I think this is interesting because I've watched this number. People still use Perl, but they're like, oh, we're still using Perl 5. And so because they decided not to allow, that breaking change to 6, you've seen 5.38. You got to understand. And then in 1996, when I was coding Perl, 97, I mean, we still were working on 4, and then 5 came out. And when when I left IBM, we were doing 5.11. So this is just gives you an example of of semantic versioning and how the minor version actually ends up being the version you care about, even though it's got the word minor in it. It's anything but minor. It's usually the thing. It's usually the thing you really want to look at, but it's not the major version. So the minor version is usually the one that you're looking at. The patch version is very easy to understand. This is only for tiny changes like typo changes. However, this does include security fixes. The only time the patch number ever gets upped is when the intended minor version is not what was intended. Does that make sense? So let me say that again with zoomed in. Okay, so the patch version is when the minor version is discovered to have a problem, right? So the patch version is like, so patch, dot zero would be the first one. There's actually, this is a fun time to say, beware the dot O. And it's kind of a thing that some of us say. Almost always when software is released as a dot O, I should probably make a video about this, but almost always when software is released with a dot O, or anything is released with a dot O, that means that it hasn't been sufficiently matured in a broader environment. And I have seen many times where whatever it is, software, hardware, whatever, is released in its initial form without, thorough, exhaustive systems integration testing, which is the kind of thing that you can only do with a very large crowd. And sometimes people will do this and they'll do a beta, right? They'll do .0 beta or alpha, and they'll put some software out there because they know that they can't actually have the volume and then of usage and the number of people using it to truly find out whether it works the way they intend. So we would always have beware the .0, right? In fact, I actually heard on another Go podcast, they have a segment on unpopular opinions, and there was a guy there one time who shared his opinion that he would never use any technology that was less than 7 years old. And I think that that's a pretty, radical way, a radically conservative approach. But you know what? The stuff that is older, what are you looking at? Is that about Go? Okay. The stuff that is older tends to be more mature, and at a certain point, particularly if you're making decisions for an organization upon which thousands or millions of dollars depend on the software you're making, people like mature things. They don't want to be trendy. They don't need to have the latest and greatest. They want things to work, and they want them to work reliably. And we're talking about this because the patch level version is one of the hints about whether you want to use a thing or not. If the patch version is greater than 0, your chances are that you're not going to encounter a security vulnerability, or that it has already been encountered. If you look at, for example, let's look at the current version of Go. And if you look at the release cycle on Golang itself, you'll see that they're 1.22.2. And if you look at the releases for everything, I'm trying to find the release history. I don't even know where I would look. Let's see if we can find the release history here. Installation instruction release here. There it is. Okay. So here we go. To 1.22.0. As I said, beware the .0, right? And then it says minor revisions here. And let's just read about some of them as an example of what a patch level means. 1.22.1 includes security fixes from crypto, HTML template, and HTTP, and netmail packages, as well as bug fixes for the compiler, the Go command line, trace command. Did you see what I mean when I say beware the .0? When I say beware the .0, it means the .0 has usually got something wrong. And my experience is every .0 has something wrong. It just hasn't been discovered yet. So make sure that you look at the .1. And by the way, if you're organizing your own releases, for better or worse, you can bump the patch level to get people to feel more confident about your release, which is somewhat inauthentic. But seriously, if you can find some excuse to not have a .0, you might get people to adopt it faster, because people like me, we see a .0 and we're like, oh no, I'll give it a couple months. That's me taking a coffee break while they wait to release to find the security problem they haven't found yet. And this is the thing. Okay, so minor revisions. Let's read the other ones just for fun. 21.2 includes one security fix to command go, which is pretty damn big. The link here are the runtime metrics. 21.23 includes a security fix. Includes 2.4 includes a security fix. Dot 5 includes a security fix. I guess you can probably see the pattern here, right? The higher the patch level, the more stable the software, because that means the minor version has been out for a while, right? So when you're looking at software, you're evaluating which version to use. Sometimes the previous version, the whatever dot 10 patch level is going to be better than the brand spanking new trendy version that's dot 1 or dot whatever dot 0. So let's go back. 1.6 includes fixes to compiler, crypto TLS, fixes to the compiler, more crypto fixes. Dot 8, more security fixes. Dot 9, more security fixes. You get the point. Okay, so now you've heard a lot about what the patch version number is. Very often the patch version is synonymous with the level of security of your particular release. So don't bump. I've seen people bump the patch version. I'm sorry, the minor version when they should have bumped the patch version. And as when you do that, you got to go to a dot 0. So be careful how you do that. And by the way, semantic versioning can vary dramatically depending on what it is that you're versioning. So, for example, I actually use semantic versioning in Go, but I also use it sometimes in documentation. Not as much. Usually in documentation, I'll just use a timestamp, and we should probably do a video about when you should just use a plain old date stamp. As many RFCs do these days, many specifications for language, how languages are implemented and other protocols and things like that. They just use the latest date. They don't use semantic versioning, which tends to be used primarily for software. But so sometimes just having the latest is the only thing you care about. So like if you're reading, you're reading a blog or something and you want to know how relevant that information is, you're looking for when was it last updated. And that's really all you care about. You really don't care about, what was changed and that kind of thing. So I've seen people try to shoehorn semantic versioning into documentation, and I have definitely been that guy as well. And I feel like that's a waste of time. And now I just use date stamps for stuff. And there may be an argument for using date stamps in whatever it is you're considering for semantic versioning. So it's worth mentioning that sometimes just a good old date stamp is good to, is good to go. Introduction. In the world of software management, there exists a dreaded place called dependency hell. Absolutely. The bigger your system grows, the more packages are integrated into your software, the more likely to find yourself one day in a pit of despair. Dependency management is, and I'm not kidding, dependency management is probably the single biggest headache in any major software project, and many DevOps shops as well as SRE, system administration. And let me give you an example of why this is. So right now, we're actually going to use this example later when we totally go into Go versioning. Okay, but this is a very specific example of why this is dependency hell and why it's relevant. We are currently undergoing an evaluation and an attempted fix for some software, and I'm sorry to do this to you, Harbor, but you deserve it, called Harbor. And Harbor is this really awesome Go project for managing containers. It's kind of like running your own Docker repo. Internally, it's an amazing project, but it has one major, major problem, and I will pull it up in its own video someday later. It has tons and tons of dependencies, and it has chosen as a project to not update those dependencies. And if you go look at it, in fact, if you pull it, I'm not going to do it. You know what? I'm going to do it. I'm going to go ahead and do it. Harbor, I'm going to do it right now because I want you guys to see what I'm talking about. Harbor, let's go look at the issues on Harbor, because I want you to see what dependency hell looks like. Harbor on GitHub, and so if you click on the issues here, you can see all of these things. Not allowed to copy at all. I mean, there's lots of stuff here, but a lot of these issues are, I'm trying to find them. they're actually opened automatically. Pending for more informations, error replication can require. I'm trying to find the ones that are automatically found to be security vulnerabilities. So the problem is that the Harbor project has, for whatever reason, not kept up and decided to not update their stuff, and it's extremely dangerous. Why is it dangerous? Because their software is insecure. People are using it all over. Object add all, prevent all, tell exactly what CVE was blocking. Um, but more important, I'm trying to find an exact area. Add export CV to security hub. Nope. Anyway, so I'm trying to. There's a bunch of vulnerabilities that are actually automatically detected by GitHub, which is another reason to support on GitHub. GitHub is a place. If you're not hosting on GitHub, I don't care what you think of Microsoft. If you're not hosting on GitHub, you are going to get burned. And the reason for that is because GitHub has an active security scanning in all of its every repo now, and they will give you a report about it. And that's one of the things that I was talking about with Harbor, is that there are actually several security scans that are showing for Harbor that they are choosing to not fix. And for whatever reason, I mean, open source is constantly overworked, underpaid, as in $0 usually. So I'm not here to point fingers, but just know if you're making the decisions about what gets used and what's safe, you have to consider this. And let me talk specifically about why that's a problem for us. So our current situation is that we have used Harbor internally. That's a lot. That's not giving away any IP about. Everybody does this, and it is a problem because we depend completely and entirely on Harbor for our internal, repo, container images and everything, and we now have to maintain a fork of the Harbor source code internally because our internal security audits have uncovered more than, I think, 3 or 4 security vulnerabilities in Harbor that are blockers. These are like, you can't use this software inside of your company. And my company is very security conscious. It's a multinational, and the differences aside that I have with the security team and how they do things, they are pretty active in identifying vulnerabilities and saying you can't do that. In fact, you have until X date to get that down, or that piece of software goes away. And it's actually a good thing. I think that more companies should be more draconian, for lack of a better word, about their security practices, because we're getting owned by the laziness. I mean, I could. I'm chopping that rabbit hole off right now. I could talk about lax corporate security policies all day long. I have seen them in the Fortune 500. It's one of the things that keeps me up at night, because I know who these organizations are and I know how lax their security is. And hacker history aside, in my part, it terrifies me because I have access to see some of these systems, and I am aware of how horribly they could be taken. So what does this have to do with semantic versioning? Because semantic versioning, the whole patch level, is usually related to security, and the fact that this is a problem for me is because our internal security team, which, to be fair, is not really the most proactive. They're good, but they're not finding every single thing. They have found core problems with Harbor. And so in order for us to be compliant with our own internal security audits, we have to patch Harbor in order to use it, because the Harbor team doesn't want to use it. And so when you're talking about dependency hell, that's what I'm talking about, because this now means that we haven't even got into Go modules. There's going to be a whole video about Go modules, and we're going to specifically talk about Harbor and how that is a thing. We're going to download Harbor, and I'm going to show you all the module dependencies and everything. So that'll be a separate video related to Go. But the point is that dependency hell, as cited here in the release history, in the semantic version explanation, is a thing. And this is a very specific idea. So dependency, there are literally hundreds and hundreds of dependencies Harbor has on other free software. If you don't know what dependency hell is and the risk of it, go do an internet search for npm worm, the biggest vulnerability ever deployed through dependency management. and it was a disaster. It's really a good thing that the world recovered from it. It was so bad. So when we talk about dependency hell, that's what we're talking about. We're talking about real serious interdependencies, sometimes looping dependencies. And to be fair, one of the great things about Go is Go will not let you have a circular dependency. And at first, you're going to be really annoyed by that. You're really going to be annoyed by that. But it actually turns out to be a good thing because you never want one of those circular dependencies. It would just ruin your day. Um, so let's keep reading. The bigger your system grows, the more packages you integrate with your software, the more likely you'll find yourself one day in a pit of despair. And that's what I just described to you. Is the pit of despair is we have a corporate dependency on Harbor, and Harbor has decided to not update their dependencies, so we have to update the dependencies by ourselves, which puts us in dependency hell when they should have fixed it on their own. So that is a pit of despair. In systems with many dependencies, releasing a new package version can quickly become a nightmare. If the dependency specifications are too tight, you're in danger of version lock, inability to upgrade your package without having a released new version. Actually, this is I have another thing to talk about here. I can't remember the project. I think it was Helm. Um, but Go stopped allowing you to put require. You couldn't even do Go install with the require directives in the go.mod file, and they locked it down so you couldn't do it anymore. And I reported it. I opened an issue, and their response to the issue was putting their hands up because they had all of these old dependencies on things and they couldn't. So they were deliberately forced to keep their Go version behind because all of their dependencies on the software that they were doing were high. This is also one of the reasons that I believe Go is more. I've heard Rob Pike straight up tell people to vendor that, which means to copy the software you want and stick it in your project. Like keep the license and everything, but copy it and put it in your project. And we're not talking about a GitHub submodule. We're talking about, or a Git submodule, just talking about just putting it in your project, taking that function or two that you need and then managing it yourself. Because having a dependency of any kind when it can be avoided is a complication that you can, not necessarily add if you want to. You can actually put that stuff in there, and if you only needed to do this one thing and you don't need it to be, but then you have a problem with you not being in sync with upstream, which is now the problem we have in Harbor because we have our own fork of Harbor just to manage the dependency so we can continue to use it. And forking an upstream project is a big deal, right? So these are considerations that common people have, enterprise people have, everybody has them. What does it have to do with semantic versioning? This is versioning is how you do dependencies. As a solution to this problem, we propose a simple set of rules and requirements to dictate how a simple set. Yeah, right. I can't wait to get to the point where it talks about the major version, which is the problematic one. These rules are based on, but not necessarily limited to, pre-existing widespread common practices. This is true. For the system to work, you first need to declare a public API. It may be consistent documentation. Regardless, it's important that the API be clear and precise. Once you identify your public API, by the way, API, this is important. By the way, when I say API, I am not talking about a web API. API stands for Application Programming Interface, and this term has existed way before the web was even a thing. And I'm sick of hearing web people. I'm sorry, I was a web person. When they hear API, they think REST HTTP API, and they don't think big API. So it's important that I mention that. You communicate changes to be the specific increments of your version number. Consider the version blah blah blah. Bug fixes, we already covered that. We call this semantic versioning. By the way, semantic means that the numbers have some valuable meaning. Let's actually look at what this is semantic mean. What does semantic mean? It's a matter of semantics. What does that word even mean? The meaning of semantic is related to meaning in language, how to use semantic in a sentence. All right, let's go read about it from Merriam-Webster. Thank you. Example of semantic. Recent, let's see. How to pronounce that? Let's see. Variants or less commonly semantical of or related to meaning in language of or relating to semantics. If people say, "Oh, it's just a matter of semantics," what are they actually saying when they say that? Semantics, plural in the form of singular. The historical and psychological study of the classification of changes in significant words or forms. A branch of semiotics dealing with relations between signs and what they're referred to, and including theory of denotation, extension, naming, and truth, the meaning and relationship of a sign, the language used the audience, especially through semantics, this is the most common one. Oh, we're just arguing semantics at that point. It's like how you talk about the thing. You're not really arguing about the substance of the thing. So example, make more than semantics is at stake in the case of obesity. The debate has heightened in the wake of major diet pill recalls. So semantics is just how we talk about the thing without substance. Semantic versioning, therefore, means that the changes have meaning with regard to, what the state of the thing is, I suppose. All right, so let's go back. The keywords must not, required, shall not, should not, recommended. If you don't know about RFCs and how to read standards, which is probably its own video all by itself, it's very important that you learn how. I'm going to say this. It's very important that you learn how to read standards as a technologist. You're going to be doing it all the time. A lot of times, the source of truth is the specification. And whether or not you think you need to know how to read and understand a specification, you'll probably be required to do it. So you should learn how to do it, even if it's rather boring. And I'll do a separate video on understanding specifications and how to read them. And from that video, obviously, we're going to link to semantic versioning. But as you can see here, RFC 2119, they use a different way to identify. RFC, by the way, is really quickly, is the original way that the internet was defined. The protocols like TCP, HTTP, all of those are defined using RFCs. So again, make sure to watch for that video about how to understand specifications in general. Software using semantic versioning must declare a public API. So this is the specification of semantic versioning, and this is where it gets ugly. Software using semantic versioning must declare a public API. This API could be declared in the code itself, which is the case for Go. Oh, whoops, let me go back here. Or exists strictly in documentation. However, it is done, it should be precise and comprehensive. A normal version must take the form of XYZ, blah. Once version package has been released, this is where you can see the zero dot all the time. Once a version package has been released, the content of the version must not be modified. Any modification must have a new version. So yeah, if you are tagging versions and you force a tag on a version to be the same as the other one, yeah, no, don't do that. I know, I've done it so many times. I'm so ashamed. I've done that. I've done that many times. I'm like, oh no, I released a version that's the wrong one. And I'm like, oh, hurry, force it. By the way, that causes problems. Yeah, because the history will be kind of messed up. So you generally don't want to force the same version over again. Even if you forgot just one typo, you still want to add a patch level. So major version should be 0 dot for initial development. Anything may change at any time. The public API should not be considered stable. And this is where there's massive amount of disagreement. So let's read the next one. Version 1.0 defines the public API. The way in which the version number is incremented after this release is dependent on its public API and how it changes. Patch version must be incremented if only backward compatible bug fixes are introduced. A bug fix is defined as internal change that fixes a behavior. I'm going to keep going here. Minor version be incremented if new backward compatible functionality is introduced to the public. It must be if new functionality is added. That's the only time if new functionality is added. But it has to be 100% backward compatible. And there's a kind of an interesting thing here when they released the YAML library and they did a v3. The Kubernetes team came unglued and they actually caused them to revert a change, because they changed the number of spaces from 2 to 4 or something. And that broke Kubernetes for a while. It's kind of an interesting thing to go read about. But it's the only time I've ever seen a major project rescind stuff and release a new version that changed their thing. But the question about, the reason this is interesting is because what is an API change, right? Is the output, the output's supposed to be whatever, right? And they even documented it that way, but then they went ahead and changed it and made it 2 spaces instead of 4, but it doesn't matter. It's not supposed to matter, but apparently it mattered to this project that had a dependency on it, even though it was specified to not matter. So, having a specification is the thing, and you need to be able to understand them when you make changes. Major version must be incremented if any backward incompatible changes are introduced to the public. It may also include minor and patch level changes. Patch and minor versions must be reset to 0. Okay, so here we go. A pre-release version may be denoted as appending a hyphen and a series of dot identifiers. This is actually a really good thing. We're going to come back to Go on this. Remind me to come back to talk about this. If you do a pre-release version with a dash, it will automatically not be considered latest in Go. We'll come back to Go versioning later when we talk about that. Numeric identifiers must not include leading zeros. Blah, blah, blah. Build metadata may be denoted appending a plus sign. Sometimes you'll see this craziness like this one here, but not a lot. Usually you'll just see dash alpha or beta. Precedence refers to how versions are compatible with each other in order. Precedence must be calculated by separating a version into major, minor, patch, and pre. Precedence is determined by first the difference when comparing each of these identifiers from left to right. Major, minor, patch. When major, minor, patch are equal, the pre-release version has lower precedence, and this is super important. When I first did this in Go, I thought, what the hell, right? I thought that by having a 1.0 dash alpha, it was going to get picked up as the latest thing. It's actually not. If you add a dash, it automatically makes it lower precedence, and that's defined by the semver spec. That'll catch you, though. You'll think that you want to just put it out there and have people try it, but you'd have to precisely specify it in Go. Precedence for two pre-release versions with the same major must be determined by comparing each dot separated identifier from left to right. And God, I mean, look at this. This is crazy. This is why people don't use all that extra stuff at the end. Alpha, beta, blah, 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 blah. Backus Nauer form. Remember I said about learning how to read specifications? Yeah. One of the things you need to learn is Backus Nauer form. This is also the basis for Pagan. If you know, people know I made my own specification. Let's not continue to read about this. This is how a specification of a grammar or a language is normally defined. So this is BNF, or ABNF is another one. EBNF is another one. We'll talk about that in a separate video. You don't necessarily need to know how to read that right now, right? What you need to know about semver is that it is a thing with a major and minor patch. Let's come back to the problems with this, though. So the most important problem here that has caused some people to question the use of semver completely. Some people are adamantly against using semver in 2024. Is that right here? Version 1.0 defines the public API. So this point number, I regularly see people ignore this specification. Major version is for initial development. Anything may change at any time. Okay. And that means breaking changes. And I cannot overstate how misunderstood, abused, manipulated this particular point of the specification is. It is so important. If you take one thing away from this video, when somebody puts a 0 dot on something, that's because they don't have the courage or the manpower, the people to I'm sorry for the gender specific term there. I'm an old man. But they don't have the resources to dedicate to supporting a major version. So people who struggle with this, teams, open source teams, I could do a whole side, rant about how open source teams are underfunded and people are doing this in their own time. They do not have the energy to support the publication of a public API, which is required for a 1.0. That means that API has to be specified. So that's the second point here, right? Or sorry, point number 5. If you put a 1.0 on a thing, you are telling the world, we are going to put out a public specification in ABNF or whatever. We are going to maintain that specification, and we are never going to make a breaking change. And for many open source projects, including tiny little ones that people do on their side that become really popular, like, I don't know, Cobra. I mean, there's a lot. There's a lot of them, and so a lot of these little projects that come, if they even get a version at all. Well, I'm talking about Go specifically, but even if they get a version at all, which most of them don't, if they get a version at all, the developers of that are terrified of the 1.0 because the 1.0 says to the world, "I promise." There's people who put a 1.0 not knowing this. There are people that put a 1.0 on it thinking they don't understand that they promise to have a public API, and somebody coming along to evaluate the project will be like, "Where's your API? You don't have an API. You put a 1 on here. What the hell?" Right? And so the people who do understand semantic versioning, which you now do, you now understand semantic versioning, so you can make your own decision. But by putting a 0, you're kind of chickening out. You're like saying, "Look, I'm going to change anything whenever the hell I want to. Sucks to be you if you don't want to, if you don't like it." And by the way, that includes my team and the API that we're making. We're like, no, we're a 0. We're never going to put a 1.0 on there. In fact, sometimes I put a 1.0 on it, I totally regret it. Why? Because as soon as you put a 1.0 on it, you can't make a breaking change anymore, period. If you put a 0, you're kind of perpetually in startup initial development phase, and you can change the hell out of it. And if you change it, you have to document, hey, we made a breaking change. You remember that thing where we put a 0 in front? And it says right here, the public API should not be considered stable. Okay, now this is really fun. We're going to come back to this. Go find your favorite project. I don't care what language it is. And go look at its dependency tree and see how many of the versions in this production software. I mean, we're talking big ass production software that's used all over the world for something, including something like Docker, right? Go look at their dependency tree and see how many of their dependencies are 1 dots. On average, I would say probably 70% of the critical dependencies are 0 dots, which, according to the specification, should not be considered stable. And yet, our entire world is running on this software. I don't know if I should laugh or cry. I don't know if I should laugh. But if anything, this just shows you that there is a big problem with semantic versioning. And that is the takeaway from this video. This has been a very long-winded video, but I am a fan of giving people context in addition to the base knowledge. You now know what semantic versioning is. You know how to go read about it. You know what I think about it. You know what the industry has struggled with, and you know its biggest flaws. Semantic version's biggest flaw, I'll say it one more time, is that the major version requires the public API to be considered unstable, and yet nobody dares to release a 1.0 because they're terrified of being held to the standard where they are going to publish a public API and they're going to promise the world they're not going to make any changes. So those two forces are at odds with each other in the semantic versioning world. So much so that several teams, significant teams, I would love to find some examples if you know, put them in the comments, have decided to throw out semantic versioning completely because it's a total shit show. It really is. I mean, you look at production software that's used all over the world that is supposed to be considered unstable, and it is versioned 0 because the teams that maintain that software refuse to promise a public API with an absolute backward compatibility guarantee. They refuse to do that. So that's all I have to say about semantic versioning. That was a long video, but hopefully that'll cover all that base. Some of you can fast forward through the video and figure out what you want to do. And again, there's going to be another video on specifications, how to process them, and that'll probably be break them down into the different specification forms. And there'll be another video specifically on Go versioning, because Go is a real good example of a language that struggles with this semver problem. That's all for this video.